Okay, so as a follow-up to the telemetry visualization tool, which looks like this, and you saw previously, I just wanted to explain a little bit of backend behind the tool and some of the extensibility related components that I've added in here that make it easier to adapt this system for a variety of different systems. That is, a variety of different vehicles and different data sources, as well as recorded data sources versus live data sources, really, and then the ability to expand it to different numbers of fault alarms and different channel hierarchies so far as how the data channels are organized. So first, I guess I'll just explain a simple architecture, and I'll illustrate this with text. Really here, you just have a server, and then you have some number of clients. Now, I guess I'll just say this, the clients first. This is what you see. This is a client. The client is running in the browser, and what the client is doing is it's displaying data that it receives from the server. So you have all of this data here, and this data has it's all being displayed based on data requests to a server. And the server, on the other hand, what it's first and foremost doing is it's communicating with a data source. This could be a vehicle for live telemetry, or it could be recorded data files, just reading some data files. Then after it gets this data, what it does is it takes the data and processes it. It looks for a few things. One, it looks for faults, and it performs fault detection on these faults. It reads through all of the data and it compares it to rules and a model of the system that it has internally, and then it says if any of this data breaks any of these rules, then I'm going to trigger a fault state. Another thing that the server does, in addition to looking for faults, is it calculates correlation. These can be pretty intensive calculations, so it's pretty nice to have a dedicated machine that's working on these calculations. And these are the ones that, like I said, is correlation between channels and how much a channel varies with respect to another channel. And then what it does is it accepts data requests from from clients, and it responds to them. And so these are just the sort of basic operations. So you can imagine you have a client, which is a browser, and it comes online and it connects to the server and it requests data and it requests data. The server responds to these data requests, and also it gives it fault data, it gives it correlation data, and then it gives it the raw data, which could be displayed right here in the panel, etc. So this is a general model, and it can work for any number of clients. And you can see here, because we're sort of abstracted out where the data comes from, we can have any sort of data source that can communicate over the network with the server. Another thing that we can set up, we can configure, is the types of alarms, and here's an alarm configuration file. You can imagine making a special tool to write this, or you could write this just in the raw JSON format, which it's currently in. But you can see here we have a number of alarms. This one is a high motor voltage, and it's defined here. Trigger is right here. Left motor voltage is greater than 10, or right motor voltage is greater than 10 volts assumed. And then we have a little note here. Could be a transient due to an electromagnetic field change. Check the value over time. Make sure it's not a transient. This is just another note, like I explained in the last one, where you can capture expert knowledge. So you can fill out either with a tool or manually one of these files, and it configures the fault detection that the server runs, so the server will issue new types of faults based on the content of these files. And finally, this is an example of what a channel hierarchy file might look like. Again, you could write this by hand, or you could make a tool to generate it. But here we just have data stored, like this is subsystem is electrical system, and then a subsystem of that is it's the left motor. And then we have channels here. The name is left motor current draw. Then we have an internal name. The type is it's a float rather than an integer. It has a unit of amps, and we also have mean and standard deviation here, which can be used for data simulation. I also built a data simulator, or for other purposes like seeing how much we're deviating from the mean. And that's about it for the internal stuff.